Welcome to Bolti Books with Anjali. Today we will learn about India's solar space mission Aditya L1. We will learn about Sun and its structure, what is Aditya L1, Aditya L1 launch, land range point and halo orbit, and few other facts about the mission. Please welcome our guest editor, Mrs. Richa Parashar, Director and Co-founder ULPT Education Services and Consultancy, and qualified facilitator for AFS intercultural programs. Aditya in Sanskrit means sun. The sun is the largest object in our solar system. It is the nearest star and the source of energy for the solar system. The estimated age of the sun is 4.5 billion years. It is a hot glowing ball of hydrogen and helium gases. The gravity of the sun holds the solar system together. In this picture, solar system is shown and sun is at the center of the solar system. Sun is the center of the solar system. The temperature of the central part of the sun, known as core, is as high as 15 million degrees Celsius. The surface of the sun that is seen has a temperature of 5500 degrees Celsius. Sun is a very dynamic star close to us. At such high temperatures, there is a continuous solar phenomenon occurring that releases enormous energy in the solar system. The sun consistently affects the earth with heat, radiation, flow of particles and magnetic fields. This picture shows the structure of the sun. On the outermost part is corona, followed by chromosphere, then photosphere, followed by connective zone, radiative zone, and then the core. On the surface of the sun keeps happening flares, prominence, and solar winds. In the structure of the sun, corona is the outermost part, followed by the chromosphere. These two make up the sun's outer atmosphere. The sun's outer atmosphere is a subject of study as it affects the environment of the earth. The sun's radius is about 109 times that of the earth. Corona is the outer atmosphere of the sun. Corona is much bigger than the rest of the sun. It is continuously expanding in space and causes solar winds. Next to the corona is the chromosphere. It is the first layer of the sun. We can see the chromosphere during a solar eclipse when the moon blocks the sun. Photosphere is the surface of the sun that radiates the light received on the earth. Now the question comes, why we need to study the sun? The flow of particles from the sun is called solar wind that fills all the space in the solar system. Solar wind, solar magnetic fields, explosive and eruptive activities on the sun's surface create space weather. The changes in space weather can cause severe damage to different satellites, spacecrafts, and communication systems. Studying the sun helps in understanding changes in the space weather, thereby creating a warning system for the satellites to avoid the disturbances, damages caused by the space weather. Scientific objectives of Aditya L1. The main scientific objectives of Aditya L1 mission are to study the changes occurring in the upper atmosphere of the sun. The upper or outer atmosphere is the chromosphere and the corona. Chromosphere and corona regions cause environmental changes on the earth as well as create space weather. Therefore, studying the heating effects on these zones is useful for understanding space weather. To find the series of processes that happen at different layers or zones of the sun. This is helpful in understanding solar winds and solar eruptive events. What is Aditya L1? Aditya L1 is the first space-based Indian mission that is aimed to study the Sun. Aditya L1 is an Indian satellite designed by ISRO to study the solar atmosphere in detail and its impact on the environment around Earth. The satellite has 7 separate payloads, all developed in India. The payloads in a satellite are various instruments or machines fixed in it. They collect data and images. Launch of Aditya L1. Aditya L1 was launched on 2nd September 2023 using PSLV C-57 from Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. It was launched 10 days after the successful landing of ISRO's moon mission Chandrayaan 3. It successfully reached its planned orbit nearly an hour later. Position of Aditya L1 in the space. The mission is aimed to place the satellite in a halo orbit around the Lagrange point 1 L1 of the Sun-Earth system to study solar activities. Lagrange points are useful to watch the Sun continuously without any hindrance caused by eclipses. This helps in observing solar activities and their effect on space weather in real time. Aditya L1 around Lagrange point L1. The satellite Aditya L1 will be placed in a halo orbit around the Lagrange point 1. This L1 point is 1.5 million kilometers from the Earth, directed towards the Sun. Still only about 1% of the Earth-Sun distance. Sun, Earth and Lagrange point. The Earth revolves around the Sun. The Sun and Earth are very big, heavy and massive bodies. Both have their own gravitational forces. If a satellite observes changes happening in the space between the Sun and the Earth, it should be in a position where it can remain stable without shifting towards any one of the bigger bodies. The weight of the satellite is smaller compared to the weight of the Earth and the Sun. Therefore, it is greatly affected by the gravitational pull of the Sun and the Earth. Lagrange points are the solution to this problem. At a Lagrange point, there is a balance of forces that makes the satellite stable. Lagrange points are named in honor of Italian-French mathematician Joseph Louis Lagrange. Therefore, if a satellite orbits around a Lagrange point, the gravitational force from the Sun-Earth system and the centripetal force on the satellite balance each other. Hence, the satellites can continue to revolve and collect data with less use of fuel and energy. In this diagram, halo orbit is shown around the point L1. In this picture, Sun-Earth system is shown. The Earth revolves around the Sun at the point L1. That is Lagrange point 1. The Aditya L1 satellite will orbit around L1. This picture shows the two-body system of Sun and Earth. The Earth orbits around the Sun. Aditya L1 will orbit around the Lagrange point L1 in the halo orbit. Halo orbit is irregular shaped. Lagrange points are fixed points or points in the space around and in between two body systems where one body is orbiting around the other. In this case, Earth is orbiting around the Sun. In our solar system, Earth and other planets orbit around the Sun. The Sun is the center of the solar system. Considering the Sun and Earth as two body systems, The Earth follows a path to orbit around the Sun. This picture shows the path of Earth around the Sun and the 5 Lagrange points. On this path, on the line joining the Sun and Earth, 5 Lagrange points have been identified. L1 point lies on the line joining the Sun and the Earth. L2 point is on the other side of the Earth. L3, L4 and L5 are points on Earth's orbit around the Sun. In this picture, we can see L1, L2, L3, L4 and L5, the 5 Lagrange points at different positions. If a third object, such as a satellite, is orbiting around one of these Lagrange points, it is placed in an advantageous position as the gravitational forces from Sun and Earth are balanced by centrifugal force on the satellite. The arrow shows the Aditya L1 satellite between the Sun and the Earth. The satellite orbits around the Earth first and afterward, satellite is shifted into larger orbits around the Earth. This follows a cruise phase when the satellite takes a long flight to reach the destination orbit, followed by orbiting in the final orbit until the mission is over. Over here, the destination orbit is the halo orbit around L1 point. Aditya L1 and halo orbit. A halo orbit is an irregular shaped, roughly circular, around a point in the space. There is no object at the center of these orbits. In Aditya L1 mission, it is a halo orbit around Lagrange point 1, which lies on the line joining the Sun and the Earth. The picture shows the halo orbit around L1 point. Few facts on Aditya L1. Aditya L1 would only study the outer atmosphere of the Sun. It will not land on the Sun. It will not go near to the Sun. The satellite will be orbiting around L1 during whole mission life. The orbit around L1 will be of irregular shape and it is in a vertical plane with respect to the Earth's orbit around the Sun. The position of the satellite at the L1 point makes sure that Aditya L1 can non-stop view solar activities. The L1 location is useful as from here the satellite can access solar radiation and storms due to the magnetic field of the Sun. L1 is stable and balances gravitational forces by the Sun and the Earth. Hence, it reduces the requirements of orbital and satellite maintenance. Thank you, Richa ma'am, for joining us. Hope you like this video. Bye-bye.